I would like to very briefly sketch what is this area of artificial intelligence and machine learning today. I'm not going to make a very historic overview of history and all that. I will just say what is happening today, how to look at it, and what are the things that are coming up and what we can expect in the near future. Artificial intelligence itself is research in the area is more than 60 years old. It is a very famous conference in 1950s called the Dartmouth Conference, in which this idea got formalized. But to cut the story short, I would say it is in 1980s that it began to be taken very seriously, and with the advent of a model called artificial neural network. Very interestingly, some of you might take note that this area was developed by a medical doctor. Talking about interdisciplinarity, multidisciplinarity, and all that. In India, it would not have happened. So this doctor got interested in modeling the brain and use it in computing, and doctor by the name Rumelhart developed a mathematical model for the brain, very crude one. That is what we call today as artificial neural network. This became established. Today, if you look back, it looks like a toy, which is not at all something very great. But very interestingly, the idea of the artificial neural network lives even now. The particular software that you saw also uses artificial neural network. So in 1990s, that began to be developed, and it was used in some very restricted areas, and it more for people to do research rather than for any day-to-day applications. But come 2010, specifically 2012, we suddenly got a reawakening of the whole field, and machine learning started happening on a day-to-day affair. And the most important application that was demonstrated in 2012 was image recognition, specifically face recognition. Today, if you go and upload your photograph with your friends on the Facebook, those who are young people listening to me may not agree, but for a person of my age, sometimes I get a nice photograph of me with a lot of people, but I don't know who they are. Many of them know me, but I don't know. The moment I upload it on the Facebook, Facebook tells me who I am with. I myself do not know. So how is this possible? This is possible with machine learning models which can recognize persons. And it can recognize people even if they, for example, I put a mustache and stand in front of the software, the camera, it will still recognize me. Or if I had a mustache and I take it off, it will still recognize me. If I had a beard and I take it off, it will still recognize me. This is not surprising because we human beings can do this. But the surprising thing is now machine can do this. Now, what happened in 2012 was, it is actually a culmination of many things. One, computers have become, as we always say, they have become cheaper, they have become more capable, their memory capacity increased, their CPUs become faster, they become smaller. All of these things have happened. They have all contributed to machine learning growing. They have contributed to everything growing, so they have contributed to machine learning also growing. But importantly, in 2012, a new idea was tried out successfully. That is, to process images and recognize people. Earlier, we used some understanding of how face is recognized to help the computer to recognize. For example, you would define, okay, look at the length of the eyes, look at the diameter of the eyeballs, or the color of the eyeballs. Now, that means you are kind of hand-holding that program to recognize faces. Friends, very interestingly, most important point today is that we don't need to do that. We don't need to know how to recognize a face to make a computer recognize a face. This is a very, very important point, profound point that I would like to make. See, earlier when computers developed, the greatest idea of the computer was that you have one hardware which can run many programs. Hardware is only one. You can solve different problems using that same hardware. And for your particular problem, solution for your particular problem, you have to program. but the machine hardware seems to be is the same. It will run all the different kinds of programs. Today we are saying we don't need program also. We don't need a program to solve a problem. This is the most important change in machine learning. Earlier we were programming a solution, and in the same machine, that is an old thing. We don't need to repeat that. All machines hardware is the same. But for each problem, you have to have a program to solve it. Today we say, no, we don't want different programs to solve it. We have one machine, one program to solve all problems. I hope I have made it clear. One machine, one program, which can solve all problems. Now, this is what we human beings do. We have one hardware. Each of us is one hardware. We have one thinking process, but we solve many problems. How do we do that? We learn to solve problems. So for example, I can learn Chinese. I already know English. I already know Malayalam. I already know Tamil. I can learn any other language if given time. You don't need a different program. You don't need to change yourself. You can learn. Now, my most amusing point I would like to share is, I'm basically a teacher. And my guru is, my Manasa guru is a psychologist by the name Jerome Bruner. Bruner, very famous educational psychologist. Someone of you is interested, you can read him up on the internet. His famous book is a small book called The Process of Education. So Bruner said many wonderful things, but one of the things he said is, anything can be taught to anyone. Very profound statement. Anything can be taught to anyone. Now, interestingly, a contrasting statement seems to be true. Anything can be learned by anyone. And in this particular case, anything can be learned by a computer. Anything can be learned. So, all problem solutions are learning to solve the problem. So face recognition can be learned. You don't need to program it. It can be learned. Recognizing medical images and finding out whether something is some problem is there can be learned. Listening to Malayalam speech and understanding what it is can be learned. Translating Malayalam to Tamil can be learned. So we are having a new model of computation whereby we are saying we don't want to program to solve each and every problem. We will let the computer learn to solve the problem by itself. This is what is called machine learning. It is a very, very different take on problem solving. Earlier, to solve a problem, you had to understand the problem. For example, when I was young, I went to Cambridge to study speech and language processing. And half of my program, the MPhil program, was taught by linguistics professors. I recall my professor, Sir John Lyons, very famous linguist. What was he teaching? He was teaching about how language is structured, what are the theories of language structure, how meaning in language can be represented using predicate logic. Only after you understand how language works, can you develop a language processing machine. And then you program what you understood into the machine. But today we are saying, no, I don't want to know how language works. Give me examples of language, correctly made language and wrongly made language. And my computer will learn how Malayalam is structured. Give me examples of translation from Malayalam to English. My computer will learn to translate without me knowing how to translate. Just give examples of translation. To recognize my face, give a lot of examples of my face. The computer will learn to recognize me. So this is a very simple outlook of problem solving. It has been highly successful and it is being used on a day-to-day basis. You already saw how powerful it is with the small example I showed. Please go and look it up and try it out yourself, and also show to people who are non-technical. They will also be surprised how the computer is able to recognize what you are just ruling, which is not very clear to even to you, but it is possible. So today, machine learning has become well established. It is possible for us to develop a solution for a problem in almost no time without being technically very capable, the young students of computer science who are listening to me must note that all those who are claiming they have developed machine learning models and softwares, please understand they have done no programming. There is no programming in machine learning. If you go to the package called TensorFlow to develop a machine learning solution to a problem, all you have to do is just like plug and play. You just call certain functions one after the other, and then the model is made. That is all. The greatest thing you have to provide is data. This I will stress again. If you want machine learning to be successful, you must have example data. And that is all you need to have. There is no other challenge. Given enough data, a computer today can learn anything. I tell you, anything. For instance, I will give you some examples with the persons themselves. On the net, you can find large number of machine learning solutions whereby if I show my face in a camera before that software once, it will record it and it will train itself. And later, if I come in slightly different dress, different lighting, in different distance, it will recognize me. It's a very powerful application used for security. Like in an office, all the people in the office, their image can be recorded. And you don't need a fingerprint scan. People can just walk through the veranda. It will know whether this person is from the office or outside. It is very easily, it will identify. You may note what is the need for this. A security person can also identify. But imagine, like a couple of years ago, there was Sabrimala, there was a lot of agitation. And the police feared that during that agitation, criminals will come and enter and try to create riots and all that with ulterior motives. And what they did? They put a face detection camera. This camera will scan the people, thousands of people in its view, and try to see if any of the criminal faces which is fed into the computer are there in the audience. Now, can a policeman do this? Just imagine, the policeman will go crazy. He looks through the binocular, looks at the face of everyone and check whether they are one of the criminals that they know of. That is very, very, very difficult, almost impossible. And also the person may not come in ordinary shape. They might be putting some headgear or putting a beard. All that is taken care of by the face detection camera. So this was used in our state itself. Now, I will tell you the kind of things such a camera can do. I come in front of the camera. It tells me who I am. That all of us know. The Facebook does this. Who I am. Number two, it will say that I am an Indian. It will find out my race. Number three, it will guess my age. I do not know whether you can guess my age. You might look here, wrinkles and gray hair. Now, we do not know how the computer does this. Computer can correctly guess my age. It can guess whether I am a male or a female or neither. It can guess whether I am happy, whether I am confident, or whether I am sad. It can guess what are my emotions. Now, this is a very tricky thing. I will come to that. Now, these abilities are near perfect. How much a human being can do, the computer can today do. And what is required to do is, do you need any high technology? Nothing. Nothing is required. What is required is just photographs of 10,000 Indian people, photographs of people in each age category, photographs of people who are 5 years old, photographs of people who are 6 years old, photographs of people who are 50 years old. If you give all this data, the computer will find out for itself how to recognize faces. Many of the listeners might remember that some years ago, there was a very viral app, not some years ago, some months ago, just before the COVID, maybe last year, 2019. There's a very famous app called a face app. I think some of you might have tried it out. If you give your face, it will show you when you are very old, how you look like. Or for people like me, I don't need to be shown how I will look like when I'm old, because I'm already old. So what I do is I will ask, how did I look when I was young? That I can check with my old photographs also. I did so. Now this face app was a very clever ploy to extract data. What FaceApp did was, it did not just change your face to aged face, which it could have done by installing a software in your computer and a program will convert your image to an old image. But what it did was cleverly, it took the image from you, sent it through the internet to the Russian server of that app, and it converted it there and sent you the converted image. And you know what happened in the whole process? It got 10 crores of face images from all over the world. 10 crores. Today, data is money. If somebody has 10 crores of face images, it's a very, very valuable data for developing machine learning systems. You may not immediately appreciate, but I will ask you, one student comes to do project with me, I will say, okay, our project is only 1 day. To develop the machine learning model is only 1 day. But please go and collect 10,000 photographs of people. That is not at all easy. You have to go around and look for people and photograph them. Do you think people will be permitting you to photograph them? They will feel suspicious. They will say, no, you cannot photograph me. It will end up in a police case. But FaceApp got 10 crores of photos from all over the world in a matter of about 2 weeks. Now that is to the machine learning research a lot. That will be very useful to machine learning research. But we also have a problem. You know, these things can be used in so many different ways, bad ways and good ways. It has been identified that they can be used in bad ways. So, for example, in US, in some states, face detection is banned. Public institutions should not do face detection, either for security or for giving services. It is banned. The reason is that it can be used for racial discrimination, even gender discrimination and sexual discrimination. And so it is banned in some places. The seriousness of the issue has been understood. Imagine that, I go for a meeting with the chief minister. I sit in front of him, or with the prime minister, whoever it is. I sit in front of him with great amount of respect. But there is a camera which reads my face. And it tells the chief minister or the prime minister, see, this person sitting in front of you, very angry with you. He is not showing his face. That is not being shown in his face. If such a system is going to come into practice, it is going to be a very big issue. I remember as a young boy I read a novel, for children's novel, called Manasarim Yendram, a machine to read the mind. Actually, machine learning is a machine to read the mind. It can read facial expressions and read emotions. Imagine that it can cause a lot of issues. You put it in a classroom and a camera on the face, and it recognizes people who are sexually aroused. This could be a very, very serious issue in future. People who are politically agitated, all this can be read. Very dangerous. So with face recognition itself, all these issues are going on. Now I come to a very, very important development, which is already on commercial trials, which is, most of you must have heard, the driverless cars. A driverless car uses machine learning. Of course, it also uses a lot of sensors. But the core of it is a machine learning system. And what does it do? Do you know how a machine learning helps a self-driving car? A car is taken, new car with a driver, human driver, and there is a camera connected to his forehead, so that whatever he sees is recorded by the camera. Then there are sensors connected to the steering, to the clutch, to the brake, the gear, everything. And the driver is asked to drive the car for 500 kilometers, wherever he wants, in whatever traffic. So he goes on driving. When he goes on driving, all his movements are recorded. The steering, does he turn the steering to the left or to the right? How much clutch does he press? All this is recorded by the sensors. And what the driver sees is recorded by the camera, video camera. And after he drives 500 kilometers, this camera, the video of the camera and the data of the sensors from the steering and clutch and all those is given to a machine learning system. And the machine learning system simply learns to drive. No other further instruction is to be given to it. It learns from the image that the driver produced. What the driver saw, it learns. And very surprising thing, we don't need to tell that you have to go through the left. You have to always be on the left if it is in India, or in America you say it must be in the right. If you see a man jumping, then you must brake. None of this need to be told. It is all learned. If the data contained a person jumping across the road, then this would know. Now, driverless cars are on roads in some places. It has also killed one person who accidentally jumped across it. You're not too sure whether it is 100% perfect. But you know, these things are, initially there will be dangers and all that, but accidents and all that. But we should hope that all that is going to be solved, because it is tremendously becoming perfected. When it comes, what will happen to our country? Do you realize? Our development model is going to change a great. For example, you know, making roads is a very important part of development. And to provide the roads in great quality and to maintain the traffic in the roads, you have to have traffic lights, traffic policemen, and you have to have traffic lights, and you have to train people to follow traffic rules, which is a very difficult thing in India. Our sense of traffic is very bad. Some people say in America, you drive through the right. In England, you drive through the left. And in India, we do neither. We drive through the middle, whatever it is. Now, in another 10 years, we might find that our roads are full of cars without drivers. When the cars are without drivers, cars are driven by algorithms. And algorithms can be programmed according to traffic rules. So no vehicle will break any traffic rule in future. And you don't need a traffic policeman or women. You don't need traffic lights either, because all vehicles are logically programmed. They understand which vehicle is approaching from which side. The other vehicle also understands where this vehicle is going. Every vehicle communicates their information and their intent to the other vehicles. And therefore, they don't need to be regulated by an external agency. So there are no traffic lights. There are no traffic wardens to enforce traffic rules. And the vehicles don't need horns at all. The information is being passed to the next vehicle. When you turn a road, the other vehicle knows this vehicle is coming. Why do you need a horn? So you don't have horns. You don't need light either. Traffic, you don't need light on the road, because the vehicles are traveling by using its sensors. It is traveling, and the roads can be very dark and the vehicles can travel. And ambulances don't need to scream. When ambulances come, they give an information to all other vehicles. All other vehicles will move around and the ambulance can just travel. You wouldn't even know. And the efficiency of the car will increase, arguably, because it is one person less. The driver doesn't want to travel anywhere. He is just there because he has to take people. So the consumption of the fuel will come down. You don't need parking spaces. Actually, cars can be parked anywhere. Even in the middle of the road, one car can be parked. The other cars won't complain. They know that there is a non-stationary vehicle. They will move accordingly. This is what is going to happen. So, if we don't plan for this future and we build a lot of roads, large number of roads, we will be in for trouble. I also think that we might have other developments like, you know, like the small flying cars that could come. We know that the drones are going to in the second stage, where drones are going to carry material. For example, you know, small food packets to carry postal articles. You know, to a very remote place, you don't need to send a person to deliver a postal article. You know, this drone can fly and deliver. This online food also, I suppose, is already a big trouble. You know, that people are relying on online food, and the lifestyle is going to worsen. It will worsen further, because, you know, you don't even need a boy to come and deliver it to your home, and you don't need to even go to the gate to collect the food, because the drone will know which window is open or door is open. It will even come to near your bed and deliver. It is possible. You just need to have your mobile ready with you. So these kind of things can happen. It can topple all your plans about development. and how we plan to spend our money. And it will also throw off a lot of jobs. That is also going to be possible. Now, I will like to make a comment about this word deep learning. Now, I didn't mean this lecture as a technical lecture. If so, I need more time and need to use presentation. But I would like to tell you, one kind of machine learning is called deep learning. In deep learning, you take the data, raw data that from which you have to learn, and using successive layers of analysis, you extract very deep features of the data and use that to recognize the data. So I will call it, in our Indian term, I will call it Divya Drishti. The computer is able to look into data and see what ordinary people cannot see. That is why I call it Divya Drishti. And today, it is possible for us to see what the Divya Drishti is seeing, even though we cannot understand, because the machine learning reveals what it sees. And we can see very strange patterns, very, very dreamy patterns of information from your face that the computer is reading to recognize you. But we don't understand what it is. It is not humanly understandable. In fact, using these methods, some very creative things are also happening. From Google, Google has developed a technique called deep dreaming. I asked my friends to go and ask Google itself about deep dreaming. And you will see the computer has generated highly creative, imaginatory pictures, which very much look like a crazy dream. And the computer is able to continuously generate such pictures. The computer is able to generate new fashions, new haircuts. All of this it is doing today. These are called deep dreaming or generative machine learning. Generative machine learning. So it is not only recognizing, but it is also producing newer patterns which has not been seen so far by the machine. So I would just make a small academic remark for students who are listening to me, who want to try out machine learning, do projects, understand. As a person who has worked for 10 years, 30 years in machine learning, I had to retrain myself recently to understand what is going on in the sector currently. And based on what I understood, I would like to tell you, there are too many things in machine learning that is happening. If you try to understand everything of it in the first instance, you will drown in it. There is so much of development happening. So as a teacher, my duty is to tell you, guide you to one route to begin with. After that, you can take your own route. So the route I would suggest is, please try the network called, the machine learning system called convolution neural network, CNN. Don't fall into the temptation of looking up anything else in the beginning. Just try to master convolution neural networks. And what tool to use? There are many tools for your choice. I would again say, without permitting any argument at this point of time, I would like to just tell you, please use TensorFlow. TensorFlow is a platform to develop machine learning. So my quick advice to young friends is, try CNN in TensorFlow. And please remember, studying machine learning is not at all a highly technical thing, because there is no programming involved. There are only function calls. There are only small kind of statements which are one after the other, add up and make the machine learning system. In short, I would like to tell you, in about one A4 page of code, you can develop a machine learning system that recognizes digits. There's a very famous standard digit data set, handwritten digit data set, 70,000 digits. It's called MNIST. You can use that and one page of code to develop a handwritten digit recognition system. It is so easy. And one page, that is all the code will come to. And that code has no logic in it. It is only some statements which call certain functions. So I think what the information that I gave will be very useful for students, because it will give them a very clear indication of how to attack this area to gain mastery. So in summary, I would like to say that machine learning is a method newly developed in artificial intelligence or newly matured in artificial intelligence, where learning happens by providing large amount of data, and the problem solution is learned from the data. A very famous example that people often mention is, how do you calculate the cost of a house? If the cost of my house is to be calculated, I have to give a drawing of the house. I have to give the measurements of the walls, the thickness of the windows. If all this information and unit price is available, then you can multiply the volume by the unit price, add it up, you can get the price of the house. In machine learning, what we do is, we produce photos of 10,000 houses and the cost of those houses, actual cost of those houses. So the machine learns how to cost a house, and then you give a new photograph, it will predict what is the cost of the house. That is what machine learning is. In machine learning, as data increases, the performance of the system increases. And the challenge of machine learning is to provide quality data for the machine to learn. If quality data can be provided, anything can be learned. For example, a student wants to learn, develop a system to recognize Dasha Pushpam. I show my mobile on top of a plant on the roadside. It should tell me if it is a Dasha Pushpam. If so, it must tell me which Dasha Pushpam it is. If a student wants to take up this project, I will tell you, this project needs 1 day to do. Provided you have 10,000 images of Dasha Pushpams. Now, taking 10,000 images of Dasha Pushpam is challenging, but not very intellectually challenging. It is only that you have to go around and take these photographs. That is the only challenge. So I stop my presentation here, my speech here, and I would like to, I have not covered any ground, neither did I intend to. I've just thrown up some ideas, disorganized, but I hope there has been enough trigger for you to ask interesting questions and have a discussion. So over to the participants for discussion. I would like to tell the participants that in China, one of the, I would say one of the worst countries I know. I've traveled in China. In China, in the classrooms, they put a camera. And the camera, it seems, will tell the teacher who is not seriously listening. So I dread to imagine that our classrooms would become like that. I just told you, because if there was such a camera, then I would have caught who was not listening.
Okay. Dilip from Kannur.
Dilip?
Yes, sir.
From where? From where?
Kannur, Pariyaram.
Kannur. Okay, Pariyaram. Please tell me.
A very nice presentation, Doctor. And I have 2 questions.
Yeah.
One thing is that you said the machine itself recognizes the pattern based on the data we give.
Yeah.
So, is there a chance that we give the wrong pattern? For example, the case you give driving, if you take the examples of driving in a very good country where everybody has a good driving pattern, it learns that. But if you take a sample from Indian driving situation, we will learn all the, not so good.
True. Yeah. The learning depends on the quality of the data. So if you carefully curate the data and give what it should learn, what it should not learn. So it is like, in our campuses. In our campuses, inside the classroom, we have great quality of ideas discussed. Human rights and, democracy, pluralism, secularism. But as soon as the student comes out of the class, the Gunda leader comes and catches him by his throat, and there is nobody to help. And he says, you should not be not joining us. You should be coming at us with a march. What is happening is, in the same campus, 2 education is being given. One inside the classroom, an ideal education, and outside exactly opposite of it. So the student is actually learning from both. The student understands that democracy is not practical, because this is what is practically happening, and the teacher does not come to help either. Society does not come to help either. So machine learning system is crucially dependent on what you give as the data and the quality of the data. So that point is well taken.
Second question is that regarding the robotics, some of the recent developments in robotic arms used in industrial applications,
Yeah.
They have a program called like they don't have to program the robotic arm; they can just move the robotic arm and it learns by itself what to do. And this also comes under this one, or because we are not giving any data as such, it is just sensing the movement of the motor and giving a feedback. I don't know. I think it's like that.
See, I do not know what exactly is the arrangement, but it is very possible that you have a small session with the robotic arm in which you help the robot arm to do certain tasks. And when you do that, it automatically records that data. And then it trains itself on that data. This is possible. When you said that, I remember a very famous exercise called broomstick balancing experiment. Broomstick balancing. So you can again ask Uncle Google, it will tell you about the history of this experiment. Earlier, robots were able to balance a broom in their hand without falling down. We also, when we were kids, we tried to do this. So that is possible to be learned, provided you initially help it to do that. And then during that help session, it will record how the movement is to be done. And then it trains and then it does automatically. So that is possibly what was happening in the example you cited. I didn't see the question fully, but
the question is that if we have a limited number of data, actually what happens is that machine will make some mistake.
Yes.
That is what is going to happen. And can it learn from that mistake and makes its data stronger so that the requirement of actual correct data is not needed. That is, it can make the data stronger and stronger. That also is a process of learning that we usually do in our life.
Yeah, this is possible. Yeah, this is possible. But to augment the data with the feedback in a very large quantity may not be possible. Then some mistake is made, you can add that to the data. Your correction can be added to the data. But ideally, a machine learning system needs a large volume of data to have good performance. In fact, a definition of machine learning system itself is that a system that's performance increases with the volume of the data. So even though when it makes mistakes, we can augment the data by taking account of that mistake. To create 50,000 mistakes and then carry over the data to the data set might be practically impossible. So it is better to have a very large volume of data to begin with. But it is possible. The answer to your question is yes. That is also something done in machine learning.
Yes, thank you.
Okay.
So my name is Anish Klitus.
Anish.
I basically, I'm asking from a different perspective. I work for a utility, municipality, basically can say, which is looking after the utilities. And they've got a program where they wanted to actually install sensors within the drainage network and the pressurized networks. And the data gets collected all the time. Now, I basically support the client from the client side to basically, basically propose that machine learning can be applied here for decision making. But my question is, from the client perspective, because client basically would actually give this to a consultant or a contractor who will actually do it for them. So from the client's perspective, what support or like what documents or best practices or industry guidelines are currently available, which the client can use to basically put a good specification and good requirements that will basically help client get more value out of this consultant or contractors, because they don't want to actually get into a thing that's actually very expensive and get a product that's actually not very effective.
Is it, if I understand your question right, you are asking how do you evaluate the quality of a contractor or a consultant?
Yes. So if a consultant is doing this from the client side, they have to make sure.
I understand. So this is a standard problem, like in credit evaluation. In banks, they do, if you give a loan of such and such amount to this guy, what is the possibility that he will pay it back? This is to be estimated. When you do it wrongly, you get people like Vijay Mallya, running away with money. So this is possible. The brief answer to your question is yes, this is possible.
Okay. is there some support documents or, like where we can refer to? Like, is there a industry practice guide or a manual or a specification?
See, this is a kind of a research problem. So I don't think there will be an established manual for that. But I'm sure there are research papers which report similar kind of work. You will have to dig it out. I don't think there might be a standard, well-set document.
All right. Okay. Okay. Thanks.
Good afternoon, sir.
Good afternoon.
I'm Joe from Kannur, Pariyaram. I'm the principal of Nirmala ITI, of whom Father Binoy was telling. I studied in NSS long back. NSS, yes.
What
I
a
have
pleasant-
attended. Pardon? Yeah, it's nice. Well, I was very happy to see that you are joining the session of this science series by LIPI. And just one small doubt that came into my mind about this machine learning is that how we will address the ethical side of this, no? As you were saying, people can be the mind reading is possible and all.
Tell me, go on, tell me.
What will be since we know the mind reading is possible and many other applications are there, so what will be the ethical side? How can we address this ethical side of the machine learning aspect when it comes into practice, like, no?
Yeah, I already indicated that there are a lot of ethical issues that are going to be raised. With simple face recognition itself, we have serious issues. Like you recognize the race of a person or even sometimes religion of a person, the likelihood or the mentality of a person. For example, to look at somebody and say, we won't let you into the country because you look like a criminal. Can you make such systems which can do that? So they raise serious ethical issues. I think the governments all over the world have started addressing it. And most of these are actually have a potential to violate human rights and intrude into privacy, intruding into the mind, not only just the body, privacy of the body, but to the mind. So these need legislations, these need awareness by people so that these are managed. That is the only way.
So nicely presented this beautiful topic, and it's quite interesting, so that it gives a kind of promotion for searching about this more.
Wonderful. Thank you.
Thank you.
Elvin John, please come on.
Sir, is IoT a part of machine learning?
Well, you cannot say it's a part, but I would say machine learning definitely uses IoT to develop many applications. For example, IoT, is basically consisting of a large number of sensors. And if you look at, for example, the driverless cars, machine learning can happen only if a lot of data is sensed and given. And therefore, and you can say the driverless car system is an IoT because other cars also have data collected through their sensors. They exchange this data. So they're all partners in producing modern solutions. You cannot say it's a part. If you ask me, I would say it is not a part. It is a collaborating technology. That is all. Like smart farming also, IoT is used and then machine learning is also used.
Okay. Hello.
Sir,
Yes.
Namaskar, sir.
I am Babu sir.
Yeah, proud that you are listening to my talk.
Yes, very interesting, very interesting. In fact, one of my students and I worked in artificial neural networks some 25 years ago. I left that field, but he has been pursuing it vigorously. And I come across several ideas once in a while.
Okay.
So, as far as I know, the basic idea, technical idea, is that of perceptron. Is there any significant development to that idea during the past decade?
Okay.
Multi-layer perceptron.
Okay. Sir, a very precise question, and I am very happy to tell you that the perceptron lives on. It is still alive in almost the same form, and the convolution neural network, it has two parts, important parts. The first part is called a convolution layer, and it uses the image convolution to extract features, and thereafter it is passed through a multi-layer perceptron. The only difference is that today we can have many layers of perceptrons instead of one. Earlier also it was possible theoretically, but nobody did, because it will be very computationally intensive. But now we don't have a problem. We can add 25 layers just like that. So the perceptron is alive and in use inside the modern machine learning system. That is the point that I would like to.
I see. Clear.
Sir, I'm from Hyderabad.
Yeah. Tell me.
I'd like to know what kind of revolution could we have once quantum computers come in machine learning?
Yeah, I already indicated to you one, the driverless cars. I think it is the topmost application that machine learning can deliver. I told you it is a combination of other things also. It uses large number of sensors, and a communication network is also used. The cars send data between each other. But then the most amazing part of it is the machine learning thing. So that machine learning uses convolution neural networks, which I mentioned that you must try to study first. So the best application it might deliver, to me, it looks as if it is driverless cars. Then on translation, also we already have solution delivered, I would say.
So shall I ask a small little
please
guidance? That is, what are the readings that you may suggest for an initial learner of machine learning?
What is your background? The learner could be ordinary learner or somebody who is familiar
technical,
with
those who are in the technical field itself, maybe after the ITI or even diploma. Yeah.
Okay. If you let me be modest, I will suggest you to read a small article I have written, which is coming up in the Computer Society Communications this month.
Okay.
A small overview of this comes in the Computer Society of India's Communications. So I've written it specifically aimed at people who have some idea of AI, but do not know what is happening at the latest moment. Okay. So that's a very small article, but I hope that will be a good trigger for people like what you mentioned, who want to get a direction. And then for the others, it's very difficult to say a single book. But I would like to tell you, if you look up the Google and search for convolution neural network tutorials, I think there are many excellent ones. And I would like you to remember that keyword, CNN tutorial, convolution neural network tutorials. And you will get excellent material. There are certain other books also, which I would rate as very good. For example, Deep Learning Using Python. This is written by a person whose name I don't remember, looks like a French name. The person is the author of Keras. Keras is a package which is used in machine learning. So that book is very good. So if you email me, I can send you that name of that. If there are no further questions, I will hand over to the...
Excuse me, Professor Archit, I see two more questions in the chat box. One
Please,
from...
can you read out?
Yes. Are there any place where machine learning research is going on in Kerala? This question posed by Dr. Vijay Kumar of CUSAT. Number two, what do you see as the future of research in social sciences? Will this be revolutionized? Yeah.
Okay. On the first question, I think, most of the engineering colleges, most of the university departments of computer science, they do work in machine learning. In my university, we have two departments. One is the Department of Computer Science, where I was originally the professor. Now I work with the Department of Bioinformatics. So in bioinformatics itself, we have a machine learning team, and we work with machine learning. Now I think a large number of institutions even offer MSc Computer Science with specialization in machine learning and artificial intelligence. So it is all around the place. Most institutions, I think, they have started using these applications for various things. For example, even Rajiv Gandhi Center for Biotechnology, they do certain projects, they need this application, they use. The Srijitra Institute of Medical Science and Technology, all engineering colleges, NITs, university departments, some work is going on. There is one more question. What was that, sir?
Well, what do you see as the future of research in social sciences? Will this be revolutionized?
I indicated that, like reading mind of people is a job of a social scientist. So it will have tremendous applications there. I fear it will have tremendous applications there. As you may know, in social sciences, unlike science, there are no instruments. There are no technical instruments. The instruments of measurements are actually human-made and made of ideas. For example, an intelligence test is considered to be an instrument in social science. So I think we will have a big change there by bringing machine learning into the picture. It will be able to, for example, theories of education are going to change because we now have a direct measurement of the performance or the motivation levels of students in classrooms by machine learning systems. So there will be some change. I'm sure that that is going to be there.